This is our first introduction to Safran Risk session for the year. And we're going to do that. If you have a colleague and maybe she or he couldn't make it, we're going to have one in 5 hours for the Americas too. So we have some slots available if you want to tell people. Otherwise, we're going to do this on a monthly basis. Today is going to be a basic introduction to Safran Risk. Every one of the sessions is different. I always want to give it a different twist so people can see it. You can see it in our YouTube channel, in our video library, in our website as well. So welcome again. Why is it that we're here? Is because we want to introduce you to Safran. Safran Risk is the prepared software for project control professionals around the world who are searching for tools they need to manage complexity with ease. And that's something that we actually share a lot. Whether it's, time critical, asset intensive, resource constrained capital projects, or even high risk research and development projects, Safran designs smart solutions that help you make the best decisions. And we're going to see that today. It's going to be a very fun chat, and please don't hesitate, as Sam said, to add your question to the chat or to raise your hand. Right? I'm going to be looking, I have 2 screens, so if you see that I'm looking like this and that, it's because I have these 2 screens, and we still have people joining the call. About the Fairfield, this is us. We're experts in QRA. We have dozens of years of experience. Within all the members of the team. We're a platinum partner with Safran Risk, meaning that we are in charge of parts of their services, right, in terms of training and consulting, right? So every month, I or Doug, which is our colleague, we are the responsible for doing the certified fundamentals training. We're actually starting one in Safran Risk tomorrow. If you are interested, you can contact Sam, and we still have 2 or 3 slots available if you like. And also we're going to have one in February the 11th. We're going to have an advanced Safran Risk training February the 17th. So we are all in with this very, very phenomenal group. Right? So this is us, and let's start. Today, we're going to show you 2 cases, right? One is we're going to import a P6 file, because that's the strong part of it, right? Is that most of the time you guys will have P6 file, and this P6 file, you need to do some basic stress analysis. So this is a quite familiar case, and this is the first time that we record it. Normally we use it for our demos, but now we're going to record it so you can all see it in our YouTube channel. And the second one, and we're going to import this file so you will see how easy it is to generate a basic stress analysis. And then the second one is to open an integrated cost and schedule risk analysis. Then we're going to open a resource loaded file and to see how to manage cost. And then we're going to show you how is it that the cost module that you have in Safran Risk can be utilized as well, right? So you will have at the end one cost, which is the one that comes with the resource loaded model, and another cost. That's the one that you can run. Why? Because sometimes people use different external tools to run cost analysis on top of Safran, right? So you have Safran for the schedule and then another tool to do the cost analysis. Here, I'm going to show you how to do both using Safran, right? So I already have Safran open, and what I'm going to do, I'm going to use this external project file that we have here, right? I'm going to use it, and I'm going to import, right, an XCR file. So once you select the XCR file, right, these are the Primavera files, and starting in version 22.2.36, which is the one that I have, you can also import OPRA files as well, right? Be registered from the Primavera Risk Analysis as well. So this is something new just for you to know in case you're wondering, right? So you read the file. This file is a small, has, I think it's 40 tasks or something like that, 43 tasks, right? You choose the planning unit, which is going to be days. You can map uncertainties. You see, I have some uncertainties here that I can map, meaning that you're not going to lose everything that you have as uncertainty from P6, and I'm going to show you in a second. And this is something that we have already recorded in a video in our YouTube channel. So we go to next here, right? Sometimes you have some constraints or some warnings here before you can utilize the file. You have some preliminary checks that the software does. You click on next. If you like, you can take a look to how many activities, links, resources, calendars, right? The philosophy of Safran Risk is that everything that you have in P6 is going to be imported, right? And let's say, let me change the name. This is the date, right? Tests, Run version 2, test stress analysis. Let me see. This is for this file. And now the project is saved to the database. So you will see that in Safran Risk, you don't have different files to save the information on the programs and your risks analysis. You have a database. You have a SQL Server database in your computer that you will have to set up. But what does it mean is that the robustness and the speed of all the simulation processes, as you will see, it's much, much faster, right? So I will close it, and that means that right now I have this XDR file, right, imported into my computer. So you will see into my Safran Risk. And then what you see here is the Safran projects view. Safran project is a tool also from Safran that comes with Safran Risk. This is like an reduced version of it that has pretty much everything that you will need for your risk analysis. You have a complete layout manager here. Normally during the trainings, we take a look, and also we give you all these layout files. For example, this is the import check. The import check checks, of course, if you have differences. For example, maybe it's a rounding. I know this is a rounding issue that you have, so that's why you have a difference there, right? But also you can have different layouts built that you can build, or you can send it, or you can be sent. For example, things like, for example, here, remember that I had some duration uncertainty. So I know that the duration uncertainty is here, you see. So I can find the duration uncertainty that I brought from P6, right? From my P6, I had this, meaning that I didn't have to do anything right now to run the uncertainty, right? It's very simple. I'm going to run it in a second. So you can do it like this, right? And you can change it. You have the ability to change the distributions too, and you have different layouts here. In the view menu, also you have the ability to take a look to, for example, here, let me choose the Primavera one. That's going to be very similar to the one that you use every day, right? And if you don't see the tasks, of course, you have the best fits, the overview, and you have the typical timelines or symbols or all the things that you normally do here, right? It's the typical menu. You have filters as well here. So you can see, for example, if you want to see tasks that last more than 30 days, so you click here, and then voila, you have the tasks here that last more than 30 days. If you like, you can take a look to the filter, and it's very basic, right? It says the duration, it's more than 30 days, right? So you have a complete manager. You can also even add, delete, link, unlink the tasks, depending on the size of your team, depending on how is it that you run it, small. So that will be great. Right? Now, so first thing that we're going to do, we're going to add, remember the first use case was to add a stress analysis. So one thing that you could do, you could add to the risk of the model, you could do what we call a project risk. And you say, well, project risk here, new, this could be, for example, R001 stress analysis, like this. And then you add it like that, right? Let's say that this is going to be an estimated uncertainty, right? That means that the probability is going to be 100. Right? It's not going to have probability of happening. No, it's going to happen whatever it takes. It's going to affect the schedule, right? And you can say, well, it's going to be a per distribution. It's going to be 80 to 120%, right? So we're going to apply a symmetric impact to the tasks that are going to be mapped to this risk, right? To this risk analysis uncertainty. Things that you can do here, you can choose the columns. For example, you can choose the schedule distribution here, meaning that you can see it as the typical risk register. And the one that we always recommend is you to see the mapping count, right? Meaning that how many tasks are mapped to this risk. Right now we have 0, of course, because we don't have any. Now, what if you have 2, 3, or 20 or 50 risks from your risk register? Right? So one thing that you can do, you can go to your global risk repository. You see, this is a general repository. It didn't come with the model. It comes with my Safran Risk setup, right? This is application level, not project level, right? And then you can have a repository of all these different risks that you can utilize in other projects. So you see that, for example, I have another one. It's called the stress test here. You see? And you can click it and you see that this is a different one. It says it's a uniform 80 and 150. So if I like, I can go to my project risks and say, you know, I'm going to bring also my other stress tests. So I click here, I click including project, and I have a stress here. Right. Now you have two. One, the one that you design, maybe this is the one that the customer asked you, and maybe this is the one that you want to do. Right? And maybe we can compare both. That's something that we can do, very simple. So next step, as I said before, we're going to apply this to each and every one of the tasks, right? This is a small model. So then you go here to this risk mapping grid, and this risk mapping grid is going to let you generate these uncertainties like this, yeah? With the UAV prototype in this case, which is my model. So what you can do, you can expand it all like this. You can see all the tasks that you have. Remember, why I only have 14 tasks? Because I have my filter here. If I disable the filter, I'm going to go back to my risk mapping, expand it, and I have it all like this. You see? So now I have all my tasks. So you see that the filters, the layouts that I showed you before, is going to be applied in all the screens, in all the selection screens. What you can do, for example, you can say, you know, I'm going to apply this stress test analysis, the one that my client asked me to do. I'm going to apply it to all the tasks. You see here, this is what we call the real-time analyzer. And it's going to show you for each one of the tasks, which are the risks are going to be applied and they're going to be affecting the task. In this case, for example, this task is going to last between 8 days and 12 days. What you can do to help the visualization here is that you can choose here, as in the project risk, you also have columns, and you can see, I want to see the duration like this. And now you can see the duration here. You see? So now you know that this task that it's 40 days. If you apply the stress analysis, could last between 33 and 47 days. You see? Things that we also recommend here, you can choose to see the float, the free floats here. So you know which tasks are in the critical path or not, like this, you see. And that will be it for the stress analysis. You see, it's going to be very simple. You just select all the tasks, meaning that all the tasks are going to receive the same shock, if you like. Right? We are not adding risks yet. We're going to add risks after that in a second model. But remember that the first case was to create a basic stress analysis. So what we can do, now that we have that, we can just go to Analyze here and run an analysis. What would be the ideal flow? The ideal flow would be that you also take care here of the schedule warnings. In this case, I only have two, because the software does all these checks, right? It takes into consideration all these constraints, must finish and must start on, etc. Lags, relationships like tasks with no predecessors and no successors. Right? In this case, I know I only have two, but normally what you would do with a model that you didn't know, and the model that you received and your client says, you know, take care of this. I really like to know what is it that it's doing. So it would be great that you can take a look here to the schedule warnings. Review them. You can export them too, send it to the scheduling team. The scheduling team is going to come back with some other modifications, maybe, etc., etc. Right? Now that you have that, you go here to Analyze, right? And then you can say, well, I'm going to run it with 1,000. One thing that you see here, and this is something it's really easy, is that you can choose which stress analysis to run, right? So instead of you having to model all of this and have these switches or drop downs in Excel or with other tools, here you can say, I'm just going to run the stress analysis. I know that for this stress test is not included, so it doesn't matter right now. It's if I pick it or not, it doesn't matter. But what I can do, and this is what I will do next, I will run both and see which one hits the plan in a different way, right? So I run the analysis like this. You see that it's been, I don't know, 10 minutes, and now we have our first simulation, right? So the nice thing about this is that it's how easy it is. You see, it took me 10 minutes to build a stress test analysis and model. What you can do, you can say, you see, my P8 is going to be on April the 14th of this year, right? In like 3 months. This is my P80. My P50 is going to be April 4, my P90, etc. You can choose to show or not all these different visual capabilities, right? You can change the color here in options. You have dozens of options where you can add, for example, these types of curtains, like the one that I have here from P50 to P80. Says that from P50 to P80, okay, I have 10 days. And these 10 days are equivalent to 2% of the deterministic duration, right? This is exactly what you have here. So some companies like to run the contingency like that. During our basic trainings, our Safran fundamental trainings, this is exactly what we do. We dedicate a couple of hours just to understand this screen, because you have so many things to do here. You can change the focus percentiles as well. You see that I only have P50, 80, and 90. But you can have much more, much less, and you can have your own. What else you have here? The capabilities, the graphical capabilities. You have a way to see how was the variability of the sections of the data. For example, here, this is the project, the complete project, right? But I want to see the analysis for the finish date of the construction portion. So you can drill down and go to the construction, or you can even drill down and go to tasks like this, right? Sometimes with different tools, you will have to set up this as outputs, run the simulation, and take a look. In this case, it is already existing, and this is very simple. On top of that, things that you can do, for example, you can have what we call these focus activities. So you can select the activity and say, I want to see construction and fabrication. These are the ones that I always want to review. Let's imagine that instead of having 50 tasks, right now you have 3,000 tasks or 10,000 tasks. So the moment that you have these focus activities, I will run it again. These are very handy, because instead of you having to navigate like what I was doing, imagine you have 3, 5, etc. levels, you just have the activities here. And you can see the project completion, the fabrication, or the construction. Right? So this makes it really handy, and the tool is thought from the very beginning, from its inception, to handle very high number of tasks. Okay. What else you can do? You see that you have the finish date. The start date we didn't change it. That's why you will see a block. Right? The start date we changed a little bit at the beginning, but what I really want to show you, see here, is the duration, right, of the program. So this is the duration. So let's take a look here. The duration now you have, the duration, your P8 is going to be 638 days. Your deterministic is 628 days. So where did it come from? The deterministic, it comes from here, right? 628 days. This is the deterministic portion of it, right? So I come back, and the deterministic is going to be 628 days. Things that you can do, for example, you can say, I want to see the deterministic here. Take a look. So the deterministic has, in this case, 50% probability of happening, 52%, which is here, meaning that all of this is 52%. What happens if you have a target value of 610 days? So you say the target here, 610, enter, right? And automatically you have this here. So there's a lot of interaction between this with information that you see here. Plus you have the typical descriptive statistics, like the mean, the minimum, the maximum, the median, etc., that you can see. And so you see that now in less than 20 minutes, we already have our stress analysis on top of the finish date and the duration for all the different disaggregations of the model. Things that you can do, you can take a look to what we call drivers. The drivers are going to be shown here. These are going to be the activities that drive the finish date of the project. Remember that we don't have risks yet. We only have uncertainties. Remember that we set up in the project risks, we set it up as uncertainty, meaning that we don't have what we call risk events. And we're going to see that in the next model, right? So you can take a look to our drivers here. And you see here, what you're looking at right now is the correlation times criticality, meaning that you take a look to the criticality, meaning what's the portion of the simulation that this task is part of the critical path multiplied by the criticality, meaning multiplied by the correlation. So that means that you're blending two measures in one. Right? So these are the activities. Normally, what we say is maybe more than 0.3, 0.4. You should use for focusing, right? And after that, this is like your initial pulling through. You can run what we call a sensitivity analysis, which is built using an exclusion algorithm, meaning that, for example, in the duration, what I'm going to do, I'm going to run each one of these simulations that you will see. Let me run it and you will see what happens, right? In this case, I only have, well, one risk because this is the estimated answer, right? And what this does, remember that the previous analysis, the drivers, it generated a correlation analysis, right? The correlation analysis gives you the measure of apparent relationships between tasks and the finish date, right? Of course, if the correlation coefficient is very high, most likely you will find this correlation relationship. But the moment that you jump into the sensitivity analysis, the good thing is that this is going to give you tangible numbers, right? This means that 16 days of your P90, which is here, right, are a responsibility of risk 01. Right? That's a nice thing about that. We're going to see that in the next model. Okay? So this is the first one. You see that very simple. You just have to run the stress analysis here, right? Oh, and I was forgetting something. So what if you like now to generate a different model, but now with the stress analysis, with the second stress test, this is the client and this is ours, right? So what you can do, you can go to the distribution comparison. Let me clean this. This is from, so I'm going to clear the graphic. And what I can say is, I will take this distribution graphic from the duration. I'm going to send it here like this. And then I sent this graphic, the distribution graphic, I sent it to the distribution comparison. And I'm going to call it stress test client. Okay. And what I can do, I can go back to the risk mapping, change all of this to the stress test like this. You see, run the analysis again. See, this is now my new duration with this stress analysis and send it to it and compare it. You see, and this is going to be stress test Berryfield group. You see, and this is the one that your customer wanted to see, and this is the one that we have, right? With a difference of 140 and 24 days at P90. And of course, I can change this and say, well, what happens in the mean? Oh, yes, so we have 97 days. So perhaps there's something in our stress test that is very different from the stress test from the client. Right? And these are the types of things that you will look at. So the distribution comparison, something that, of course, we touch in our fundamental training. You see, it's very, very simple. You just have to start to send the results with this little button here, with the send to comparison. Okay, so this is the first model. We're going to close it. Okay? And I'm going to include this file in a folder for all of you guys that attended, so thank you for that. And I'm going to open another file, which is called the UAV prototype resource loader. This is a model that it's already here. It's already in my database, right? And it's the same file that you just saw. But what I did, I added some resource loading. That means, you see here, that now that I can review each task, right? And the task is going to have resources. The previous one didn't have any resource. Right? That means that this resource has money, you see here, and it has a cost, a planned total cost, etc. And you see that now I'm using the cost loaded layout that I mentioned before. And remember that these layouts you can import or export. And if I'm not mistaken, in the video from December 2024 in our YouTube channel, I will send you in a minute. I explain much more in the layouts and filters, and there's an example there with some warning sounds. So it's really, really fun and easy. Okay? So now that I have the resource loaded, now take a look here. In the project risk, I have much more project risk, right? I have my uncertainties. Remember, no stress test now. I have my low, medium, and high uncertainties that I got from my global risks. Right? I have here my low, medium, and high uncertainties that I got from my global risks. That's one. Number two, right, I also have some project risks like external communication issues, subcontractor, vendor liquidation, internal communication issues, outsourcing the fabrication, etc. Right? And even have what we call a calendar risk. A calendar risk lets you add some windows of potential downtimes that will happen during some specific months of coming years. Right? Let's say that you start right now, well, in January, it's going to be easy. We're in January, and then you can say, you say, I'm going to have, see, there's somebody there. Here we go. I'm going to have potential in January, February, March, October, November, December, let's say high winds. And that means that the testing of the file that I'm doing right now, testing of the, I'm sorry, of the items that I'm manufacturing here. This is suppose that I'm manufacturing drones. That's what this schedule is all about. We're going to have high winds. That means that you will have perhaps 1 in every 3 days, you're going to have issues with downtimes because of the high winds. And you can specify that in what we call these risk calendars here, you see. And then you can specify that. It's really fun. And of course, it's really, really helpful because if you have high wind or if you have issues with sun, with rain, etc., you can add all of this to the model, right? And include them into your project risks like that, you see? Now that I have this project risk, remember that, as I said before, I have estimated uncertainties, right? Which are the ones here, right? Estimated uncertainties. And also I have risk events, which are the ones there, like this, you see? Now that I have everything, of course, my risk mapping is just not going to be as easy as the previous one, right? You see that I have different uncertainties from different tasks. And I also have different mappings for risk for different tasks. For example, here, this overall design template has all of this, right? It doesn't have any uncertainty. Take a look. It doesn't have any uncertainty, but it could be affected by the ash cloud. It could be affected by the communication issues by the merger or acquisition. And then my real-time analyzer, you take a look, it says it could, this task could have, the mean of the task was 52 days, the deterministic was 44, but it could go all the way to 115 days. And what if I add one uncertainty? And I asked the subject matter expert, and he said, you know, this overall design is high uncertainty. Take a look here, 115 days. Now it goes, it adds, let me see here, the high uncertainty here, right? And well, let's take a look. I mean that you can pick the float to see if you have float there, you see, and also the duration if you like, to see if how is each task going to react, having or not different risks, you see, like this. So merger of acquisition, I think it's an opportunity. That's why you have 114 days. If I uncheck it, now you have 147 days. See, now you have what we call a complete model, right? Because you have project risk, you even have a calendar risk, and then you have uncertainties. Now that you have all of that together mapped into this really easy to use user interface, okay? I can run the model again. Okay? You see that now, let me go back to the analyze tab. Once I have the results, let me go back. You see that now I have the ability to tick or not each one of the risks or the uncertainties, and also select if I want to use the pre or the post mitigation configuration. So how does it work? So each one of the risks, let's imagine this subcontractor liquidation. You have a pre-mitigation position here. It's going to be between 80 and 150% applied, but I also have a post-mitigated position that I can set up. I can say the post-mitigation is going to be maybe 80, 100, and 120%, like this. And even I can add actions if I like, right? I can add actions that take duration and cost and are linked to costs and tasks as well, right? So these are things that you can do in the model that normally would take you a lot of time doing that with an Excel or an spreadsheet-like model. Okay? So in this case, you see that I added this schedule impact for this particular model, and for some of them, I have pre and post. For some of them, I cannot have. It's totally up to you. You can have also cost impact that I don't have here. And what you can see here are all the mappings of the risks like this. Right? So now that I run it, and you see that now it turned out into red. That means that I changed the model. So I want to run it again. See what happened there. Right? And what you can see is that I have my duration, and also I have my cost. Remember that this model is resource loaded, meaning that I will have my duration. Duration is going to look like more or less the typical risk framework like this. You have a duration that goes like that. It's going to look like this. Okay? And we're going to use the scenario comparison. So we're going to disaggregate the effect of the uncertainties and the risk events. Okay? And as I said before, we have the finish date, as we saw it, we have the duration, and now we have the cost. And this is something that we didn't have before, right? Meaning that now we know that the cost of the project is going to be more or less 4.5 million. Your P50 is going to be 5.2, 5.8, 6 million as the P90, etc., right? So this is the cost from the resource loaded, right? This is from the resource loaded, and the cost impact from the risks, right? Now let me show you where is that. So here, remember that I had your schedule impact, but also if you have your cost impact. So I can add a cost here that says, for example, here I can say that this particular risk, the external communication issues, could affect in 100, and 120%, whatever the cost of the task mapped to this risk. So it's going to hit the duration with this distribution, is going to affect the cost with this distribution. So you can be very, very detailed regarding these costs and the schedule impacts, right? I'm not going to run the model again yet. I have this, I have the cost, and now the drivers, you will see now the drivers are complete, because before we only had this, which were the activities driving the finish date, but now you have the risks driving the finish date. In this case, you have the ash cloud communication, the testing overrun, etc. So you have a complete sensitivity analysis. Remember, that's going to give you focus. Where should I put my resources? Or at least, as this is a correlation-related analysis, where should I start to add my costs? Right? I think that we have a question. Please, Sarvesh.
Yeah, thank you. So what does that percentage in front of these drivers say? Like 61% or 48%?
Excellent. Good. So in this case, this 61 means that the correlation that you have between the ash cloud impact and the finish date of the project is 61%. Meaning that, imagine that you have here the finish date, and here which one is it? The ash cloud impact. It means that, imagine that you have all the 1,000 samples that I built, the ones that I run, right? You will have a line here, and that line is going to have 0.61, right, of slope, if you like. Right? That's going to be the degree of relationship between these two. Right? That
Thank
means,
you.
good, excellent. Thank you for the question. That means that this one might be a candidate of having a very direct effect, right, in the finish state. You see that doing this correlation analysis is not as intuitive as going through this, right? I really like it because this is my pulling thread. These are my pulling threads. And before I go to the sensitivity analysis, please remember that you can do the same for costs. You see that, right? Risk driving the cost, the first one is the testing overrun. And the ash cloud is number 4 or number 5. Same thing, the activities driving the cost. You have the assembly field system, which is not the same as the one finished driving the finish date, which is normally the case, right? Not all the tasks, they have a direct correlation with the cost and vice versa. Okay? Now, if you go to the sensitivity analysis, and this becomes very, very interesting, is that what you can do, you can run this analysis, and what it does, it gives you, let me show you one by one here. It gives you the duration analysis, meaning that, for example, the ash cloud at P90, let's say that we go P80, because the majority of people go P80. Okay? Ash cloud is responsible for 37 days at your P80, and the poor flying conditions is 31 days. I think this was the calendar risk, 26 days for the communication, etc. in your P80. But what you can do as well, you can say, well, I also want to see, right, what is the relationship with my cost? And what you can see there is that this one, the ash cloud, is responsible for 135 million, let's say, or 135,000, right? The poor flying condition doesn't have any cost, right? So this is a good thing to see, because maybe this is wrong, right? Maybe I have to add a cost here. It's weird that everybody has a cost and this doesn't. Right? So maybe that's an issue in the model, and the communication issues with 63, etc. If you like, you can make this a little bit to the right and reorder, you see? And I can reorder the tornado chart using the schedule, or you can reorder it using the duration, like this. So you can pick and choose the one that you like, right? To do the ordering. Right? So now you have a view of cost and duration. Other things that you can do, for example, you can take a look to the scatter plot, right, of that. And I'm going to show you in a second. I'm going just to change that, the duration. I'm going to change this to duration, and to change a little bit the target value. You see here, it's a 6,000, here we go, 610 days, etc. That you can change. You can see what happens with the cost as well, right? Now, before I come here, let me go back and show you one module that I also offered to show. Remember that, first of all, we have in our distribution graphic the cost here. But, as I mentioned at the beginning of the presentation, you have another module to register cost, which is this cost, which is a CBS, the cost breakdown structure module, the one that you have here. And now you see that you have a hierarchical view of all your different costs, like this. So if you are doing, for example, a budget, or you're calculating your emissions, you're calculating your operational costs, etc., you can add one model here. Right? That doesn't mean that, for example, if I do a navigation licenses cost, my schedule is going to inherit this. No, this is an independent analysis that has different components that are shared with the schedule. For example, for the navigation licenses, what I can do is I can choose risks. In the risks, for example, the e-communication risk has a cost impact. So I can add this risk here. That means that you have in one hand your schedule, right? And in another one, you have your cost breakdown structure. And they both share the same risk register, which is really, really good, because you don't have to develop one for each one of them. And this is normally something that you don't do when you do the analysis in different Excel-related tools, right? Because you have a cost risk register that's normally not the same for the cost portion, right? So that's a good thing. That's one. And the second, if you like to be very specific with the costs, you can relate, for example, the navigation licenses. I can add an activity to it and say, navigational licenses, I'm just going to make it up. I'm going to add it here, 100%, or I can say I'm going to add here. So I'm going to add 40% of the cost is going to be related to the design GPS system dates, the design additional guides, and the specialist camera lens, right? So I'm going to take this 120,000 that I have here, and I'm going to prorate it using these fractions, right, in these tasks. Right? So that's very specific. And what it does, it doesn't take the cost and move it to the task, but it utilizes the task to do a timeline of where the cost is going to be added, right? So I can click here and OK. Right? And for this particular one, right, what's going to happen is that you will have this time, right? The time, I will say, use dates from activities, and this is what's going to happen, where, of course, it depends on. See what happens. This is the selected one. You see now that this 40, 30, and 30 are going to be prorated here, while the rest of the project is here. You see? So now I use the dates of these tasks to lay down the cost dates. Right? Now that we have this cost, as I was saying before, you can run a scatter plot, and this scatter plot is going to have duration in the x-axis, for example. You can change it, always you can change it, or you can use the cost in the y-axis. You see what I did here, and I prepared the model like this. You see that the duration here, it has the layout of the model, the original model, but the y-axis that you have there, right, the y-axis has the cost breakdown structure hierarchy. Okay? So that's really, really good. Now, what you can do, you see, you can take a look and do two types of analysis here with the scatter plot. One is what we call a target value analysis. Like, for example, here I can change the cost to, let's say, 1.2 million, like that. And I can say, well, what's the probability for me to finish the project before 610 days and 1.2 million, so it's 5%. So if you negotiated with your client that these were going to be the dates, you're only 5% probability on your favor. If, for example, you said, if the client said, you have to finish this in 610 days, I don't mind about the money, meaning that I can spend even 1.35 million, so you have 13% plus 5. If, on the contrary, right, you have a different client and he said, I really don't mind about the dates, but I only have 1.2 million. So you have this 5% plus all this area here is 23%. So that's going to be 28%. So you ask for the reference and then you get the probability. Then you have another one, which is called the JCL band analysis here, like this, that is going to show you the different ways in which you will be able to run the analysis. To make it better, let me see if I can run maybe 2,000 or 3,000 iterations. So I have a little bit more data points. Yeah, I'm not sure what happens here. I have this, like 10 models I had it open before this. So now the scatter plot, you see, it's going to be much more defined. Normally, what you have here, it's an area that you said, well, I have between 0 and 50% probability of land here. Of course, it's green because that's the best land, let's say, right? Because you have the smallest money, right? And you have the earliest date, right? So that's why you have it in green. But let's be a little bit more realistic and say, which are the limits between my 50 and 80 probabilities. So these are going to be more or less like this, right? And what you see here is the typical reference trade-off curve, right? You can see, look, if you're going to be between 50 and 80%, the earlier that you can finished, maybe here, for example, 650 days, but you will have to spend, right? You will have to spend perhaps around 1.3 million. And if you care more about the money and not about the dates, perhaps you go here and you say, you know, here you're going to do the project in 800 to 850 days, but you're going to spend 1.2 million. So you see that here you can do this type of trade-off analysis that obviously you cannot do if you have two different models. So that's something that I really, really like about the scatter plot analysis. Okay. Other things that you can do, you can have what we call a PCF graphic, a probabilistic cash flow graphic, right, where you can see all the different, for example, I can see my cumulative curve, the typical S curve that I'm going to show you in a second. Typical S curve like this. Right? Or if you like, you can have this as in a data view, right? Like a cash flow, and then you can export this to Excel or to graphic, however you like, and then you can manage and you can massage the data, right? So what we've tried to show you today is how versatile the tool is. Remember that we started with the simple stress analysis in the same file that it took us maybe 15 minutes to build. Then once we did that, I show you a complete model. This complete model is after maybe the workshops that you had where you generated this project risk with your team. After you map all these risks with the team, right? Again, workshops, and also working together, we generate all this information. Right? Remember that here for each one of the projects, always remember you have the ability to have pre and post mitigation models. Again, complying with this, right? Pre and post mitigation model. This is the framework that Safran Risk uses, right? And once that, of course, will run the simulation, you have focus activities. If you use costs, you see now, you have these focus costs. And we were able to take a look here to some of the options that you have there. How to take a look to the drivers, remember how to generate these pooling threads, whether you're talking cost or duration, and then running this sensitivity analysis that also takes into consideration cost and duration. We went through the distribution comparison. Remember that we did with the stress tests for the client or with Field, and this is the last one that I'm going to do. For example, I'm going to clear the graphic, right? Let's see how it goes. And what I can say, I say, you know, I don't want any risk to be included. I only want my uncertainties, right? So I can run it. Let me just run it 1,000. I run the analysis. Yeah, I'm not sure what happened there, but it doesn't matter, right? And I can, for example, take a look to the duration again. I send it my comparison, you see, and this is going to be uncertainties only. And then I go back, tick all, and then I'm going to run it again. Take a look to the duration and send it like this. And this is going to be uncertainties plus risks, like this, you see? And then you see that risks added at your mean added 107 days. At your P80, which is normally the one that you use, 156 days, which is basically this distance being generated because of the risks, right? Like that. You see? And then, of course, as the project progresses, you can normally go back and forth, review this mapping, generate these scatter plots, take a look to the PCFs, etc. Right?